Hi everyone, welcome to your last set of notes for the school year. So this is notes number 4. The FLT is today I'll be able to find the probability in an event that is normally distributed using the z-table. So first, let me talk about why we use the z-table. So I'm going to go ahead and bring back notes number 3. So in notes number 3, we looked at the normal distribution curve. You label the mean and then use a standard deviation to label other parts of this number line. Now, if I ask you, let's say, I want you to say, oh, find the probability of the height of a woman who's more than 65 inches. You see how 65 is right here somewhere? We actually don't know the exact percentage of this because it's not exactly 66.2 and it's not exactly 64.3. So this lesson is more focused on like what happens if you use all these in-between numbers. How do you find these percentages? So first, we're gonna go ahead and define what a z-score is. So the z-score is x minus the mean over the standard deviation. So z-score, this is the number one formula that you do have to remember. This is the mean and this is the standard deviation. Now when you are finding the z-score, if I have a normal distribution curve and let's say here's my point and I'm going to use a table, I find out this percentage. This percentage is always to the left. So the z-score gives the area to the left of the curve. So it's always on the left-hand side. So this z-table looks like this. There's negative z values here. And if you turn it over to the other side, there's positive z tables here. You never have to memorize this table. This table will always be given to you. If you take stats next year, you'll definitely learn more about this table next year. So first, let me just show you how to read this table. So for starters, it says find the probability. Probability and area are interchangeable using the z-score of 0.92. So 0.92 is positive, so I'm going to make sure that I'm on the positive side. You always start off with this column here. So notice your z-score is always going to be 2 decimal place values. So first you look at the first one, which is 0.9. So I'm going to look for 0.9 on my first column here. Now my second number is 2. So on my z-table, if you look up top, you'll see 0.00, 0.01, 0.02. Because I need 0.92, I need 0.92. So 0.8212 is my answer here. I recommend if you have a printer, you print this out. Otherwise, just have this PDF open on your Chromebook. 2.34. So first, you're going to start on this column. So it is positive 2. So I'm going to look for 2.3. There's 2.3 on my z-table. I need 2.34. So this second 100th place value is the number that you look up top. So 2.34 is going to be right here because there's 4 and the number is 0.9904. Let's try another one. Negative 0.03. It is negative, so this is the positive side. If I turn it over to the other side, I have negative values here. So I'm looking for negative 0.03. So 0.0 is there at the very, very bottom of my table. And then I need that 3. So I'm going to go over to the third column where that 0.03 is. I'm going to come down and my number is 0.4880. Negative 3.49. So first I'm going to look for negative 3.4. So it's always the first numbers, 3.4. And then it's 9. So I'm going to go all the way across to find 9 up top. Negative 3.49 is 0.0002. So 0.0002. Also notice on all of my answers, I put a 0 in front. If you just put this or this, that is all okay too. You can, this 0 up front is optional. Okay, so let's go ahead and apply this to some problems here. So scores on a test are normally distributed with a mean of 81.2 and a standard deviation of 3.6. A randomly selected student scored below 74. So first, like I did last time, you're gonna go ahead and draw your normal distribution curve. This center is always going to be your mean. Now, up top in this box, I said the z-score is x minus the mean all over the standard deviation. Okay, so I just wrote that down there. And we want students below 74. So if 81.2 is here, we know 74 has to be on this side. 74 is going to be your x value. So z equals 74 minus the mean, which is 81.2, divided by the standard deviation of 3.6. So I'm gonna go ahead and type in 74 minus 81.2, push enter, divided by 3.6. Notice that it is -2. Be careful, your z-score can be negative, so don't forget about your signs. So if I know my z-score is -2, I'm gonna look on my table. And -2 just means -2.00. So if I look here, -2.0 is right there, -2.00 is right here, so it's 0.0228. So what does this number even mean? This means that from 74 this way is 0.0228. Now, if you remember how to convert from decimal to percentage, you move the decimal place 2 times to the right. So this is 2.28%. Either way is fine. I accept both answers. Okay, so let's try another one. A randomly selected student scored above an 88.4. So again, I'm going to use the same data. My mean is 81.2, I believe. And I want to know students who scored above an 88.4. So first I'm going to label 88.4. 88.4 is bigger than 81.2, so I know it's going to be on this side. Think of it as a number line. Z equals x minus the mean over the standard deviation. X is 88.4. Minus the mean is 81.2. The standard deviation is 3.6. So I have 88.4 minus 81.2, push enter. Divide that by 3.6. And this time I get positive 2. Or 2.00. So I do need positive 2. So 2.00 is 0.9772. 0.9772. So remember, I told you everything is always to the left. So if you're more comfortable with percentages, if I convert this guy, this is 97.72%. So this whole thing right here is 97.72%. Now the question does ask you a little bit different. The question asks you above 88.4. If it's above 88.4, I care about the students who scored 88.4 and higher. So I care about this guy right here. So I'm actually quite not done yet because my answer gives, it's always to the left, the 97.72. Now if you remember, the full area underneath the curve should be 100. So this whole thing has to be 100. To figure out what this remaining part is, I have to do 100% minus 97.72%. And that would give me 2.28%. So 2.28% of students scored above an 88.4. Okay. I'm gonna go ahead and stop here for now. Let me know if you have any questions.